it's simple, but sometimes we don't think about it. But just to find with the reflecting off of the surfaces and mirrors, that flips the image around. Okay, looking through a refractor turns it upside down, and then if you look through a diagonal, it flips it again. Okay, so this will tell you how to orient it. And if you're doing the Messier, of course, it's going to be manual. You center your object and let it drift. And where it leaves the field of view, that's west. Because everything moves from east to west, okay? And then to find north, just nudge it or slew it, if you've got your clock drive on, toward Polaris. And wherever the stars enter the field, that's north. So you got to make sure that you go 90 degrees though from west, and you can get one of these little things here. These protractor, yeah, about a buck, I guess. This dollar cord. You don't need anything fancy. You don't need that or that. This right here, and you can set it on or turn it upside down. Now, if it bounces off of, say, two surfaces, you go clockwise to west, okay? Clockwise. If you go one surface, if it's an odd surface, you go counterclockwise. If it's an even one, you go clockwise, okay? It's just that simple.
So in Newtonian, you go clockwise, right? Because it's two surfaces.
Yeah. So, and if it's a refractor with a diagonal, that's one surface, counterclockwise. Because there's no other.
Right.
No diagonal straight through, it's clockwise.
Yeah. Should be, yeah. Okay. So, those are simple tips, and I've got formulas here for you to figure out how to get a field of view from the apparent field of view of the eyepiece. And you divide that by your magnification, and I tell you how to get your magnification in here. It's the it's focal length of your telescope divided by the focal length of the eyepiece. It's that simple. And then you work it through the other formula to get your true field of view. And you notice it turns out to be half a degree on the size of the moon.
Yeah, but this says 0.05 degrees. Could that mean?
He got an extra zero.
You got an extra zero.
It's a typo.
Yeah.
Okay,
So it's a half a degree.
okay.
So I put one too many zeros.
So it should be 0.5, right?
0.5, yeah.
50 divided by 100 is 0.5.
Yeah, 0.5. Okay. Now, and I guess that's about all I got. And this should get you started out pretty good on your Messier. Any questions other than the 0.05?
What's the easiest way to determine, like I've got a bunch, well shoot, I don't even know what the current field of view of some of the eyepieces I've got.
Well, they should be on the eyepiece. You should, when you buy them, it's like a Plaza, most of those are around 50. Give them, take a little bit.
Maybe as much as 60, 50, 55. most of them.
But when you buy them from the manufacturer, you'll have a designated field, apparent field of view on those.
Okay.
And then wide eyepieces, ultra wide, you know.
And they'll advertise that on.
Yeah, they'll
Oh, yeah,
advertise it.
U-WANs and S-WANs. Okay. Well, let's see, what time is it now?
Now, there's another thing you can do, is if you can get the full moon in your eyepiece, then you've got a half degree. You can kind of get a ballpark idea just from looking at the full moon with particular eyepieces.
But most nights that you're observing deep sky, you don't want a full moon. So.
No, but
Well, you have a lunar and a lunar too.
Right.
You know, and you can do those, and you're going to look at the moon a whole lot.
But the point being is, what you can do is take your eyepieces out one night when there's
Right.
a full moon, or close to one, and then you can
Get
just
an idea.
figure out what different eyepieces have and write it down
I
and
think so.
Is that the one?
keep it in your logbook.
So I don't remember being that one. Got a little video. I'm gonna check to see how long it is before I actually play it. We only got 15 minutes left, unless y'all want to run over. Let's see. This is 25 minutes. You want to watch that, or you won't? It's, okay.
Break.
Hello, I'm Sunny Williams.
Yeah,
I'm up
Jim
here on the
finished it.
International Space Station. No, I want to say where we are. So right now, we're in the Japanese laboratory. It's one laboratory out of many here on the International Space Station. It's actually on the left-hand side. If I was the International Space Station and I was flying through space like this, my left hand would be where the Japanese laboratory is.
Would it be all right to switch the lights off while we're watching them?
So now again, we're on the right-hand side, all the way on the right of the International Space Station. This is Columbus, the European module. It has the science experiments all over. You can see it looks a little bit crowded. And here we do a lot of our medical experiments. So this is Joe 2.